What if you climbed the largest mountain in the solar system? Imagine standing at the base of a mountain so massive that you cannot see the top. Not because of clouds, not because of fog, but because the mountain curves away from you faster than your eyes can follow it upward. You would need almost 3 full days just to reach the summit, if you could even get there at all. This isn't a mountain on Earth. This is Olympus Mons on Mars, the largest known mountain in our entire solar system. Today we're climbing it, step by step, mile by mile. Hey everyone, welcome back to the channel. If you're new here, this is the place where we explore the most extreme places, objects, and mysteries in our universe, from planets to black holes to the edges of what we understand. If that sounds like your kind of thing, hit subscribe, because we've got a lot more of these coming. Now, let's climb the biggest mountain humanity has ever discovered. Let's start with the numbers, because they genuinely sound made up. Olympus Mons stands about 13.6 miles high, roughly 22 kilometers. Mount Everest, the tallest mountain on Earth, is about 5.5 miles high measured from sea level. Olympus Mons is nearly 2.5 times taller, but height isn't even the craziest part. The width is where things get truly absurd. Olympus Mons is roughly 370 miles across at its base, wider than the entire state of Arizona. If you placed it in the continental United States, its base could stretch from Washington, D.C. almost all the way to Chicago. So this isn't a sharp, jagged peak like the mountains you picture when you hear the word mountain. It's a broad, gently sloping giant. Walking partway up its side, the slope would often be just a few degrees. So gradual you might not even realize you were on a mountain. You'd just feel like you were on an endless, very long hill. This is what's called a shield volcano, and that shape is the first clue to how this thing got so enormous. On Earth, volcanoes have a size limit, not because the planet runs out of magma, but because of something called plate tectonics. Earth's crust is broken into moving plates that drift slowly over time. When a volcanic hotspot stays in one place, like the one currently under Hawaii, the plate above it keeps sliding along. Over millions of years, that hotspot builds a chain of islands instead of one giant mountain, because the crust never sits still long enough for lava to pile up in a single spot indefinitely. Mars doesn't have that problem. Mars has no active plate tectonics. Its crust is essentially one solid, unmoving shell. So when a volcanic hotspot formed beneath what would become Olympus Mons, it stayed locked in that exact spot for hundreds of millions, maybe even billions, of years. Eruption after eruption, lava flow after lava flow, layer stacked on top of layer, all in one place, all pushing higher and wider. There's a second factor helping Mars here too: gravity. Mars's gravity is only about 38% of Earth's. Weaker gravity lets volcanic structures grow taller before their own weight causes them to collapse or spread outward. On Earth, a mountain this heavy would essentially crush itself under its own mass long before reaching anywhere near this height. So the recipe for Olympus Mons is simple: a stationary hotspot, an almost unimaginable amount of time, and low gravity to keep it climbing. Remove any one ingredient and you don't get a mountain like this. It's also worth noting Olympus Mons isn't alone. It sits near a region called the Tharsis Bulge, home to several other massive Martian volcanoes. But even among giants, Olympus Mons stands apart as the largest of them all. All right, let's actually climb it. You touch down at the base in a pressurized suit because Mars's atmosphere is less than 1% as dense as Earth's, and it's almost entirely carbon dioxide. Without a suit, you'd lose consciousness within seconds and be gone within minutes. Looking up, here's the strange part: you can't see the summit. Not from clouds or haze, but because the mountain is so wide that its own curvature, combined with the curve of the Martian horizon, hides the peak completely. From ground level, Olympus Mons doesn't even look like a mountain. It looks like the whole landscape is simply tilting upward, forever. The base is marked by steep cliffs called an escarpment, reaching up to 6 miles high in places, taller than most entire mountains on Earth, and that's just the edge before the real climbing even starts. You start walking. The ground under your boots is ancient hardened lava, dry and reddish, formed by eruptions that happened before complex life had even developed on Earth. Here's where the climb turns mentally strange rather than physically brutal. Because the slope is so gradual, walking up Olympus Mons wouldn't feel like scaling a cliff. It would feel like an extremely long, gentle hike, one that lasts for days. Covering the roughly 250-mile distance from base to caldera at a determined walking pace would take multiple days of continuous travel without counting rest, hazards, or supply stops. Mars's weaker gravity would help. Everything on you and your gear would weigh about 62% less than on Earth, making a heavy life support pack feel far lighter. You could jump higher and farther than on Earth too, though with no thick atmosphere to slow a fall, a bad stumble could still be dangerous. Along the way, you'd cross hardened lava flows, dust-covered plains, and channels likely carved by ancient volcanic gas release or flowing material. The sky above would glow a pale butterscotch color during the day, tinted by fine dust suspended in the thin air. And still, no summit in sight, just more mountain, stretching on. Finally, after covering that immense distance, you reach the top, and what greets you isn't a single peak at all. Olympus Mons has a caldera complex at its summit, a series of collapsed volcanic craters formed as magma chambers emptied out and the ground above them caved in over time. This caldera stretches about 50 miles across and plunges roughly 2 miles deep. You could fit a mid-sized American city inside it. Standing at the rim, you'd look down into a pit that once churned with molten rock, now cold, dry, and silent for millions of years. The atmosphere at this altitude is even thinner than at the base, a stark reminder of just how far you've climbed. Researchers studying this caldera have identified multiple overlapping craters of different ages, showing the volcano didn't erupt once and stop. It erupted repeatedly across an enormous span of geological time, each event reshaping the summit slightly. Looking back the way you came, the horizon visibly curves beneath you. You are standing higher above the surrounding terrain than any point reachable on Earth. Here's a question that keeps coming up in Mars research. Is Olympus Mons truly dead or just sleeping? Some studies of lava flows on its slopes suggest certain eruptions may have occurred relatively recently in geological terms, meaning millions rather than billions of years ago. That doesn't mean an eruption is coming anytime soon on a human timescale, but scientists remain cautious about calling it permanently extinct. Mars's volcanic history is long and slow, and features like this remind us that inactive and will never erupt again aren't necessarily the same thing. Understanding whether volcanoes like this could still be geologically active also matters for future exploration. The stability of a region is a key factor when choosing safe sites for future missions to the Martian surface. There's one more thing that's easy to miss when standing here. Olympus Mons isn't just the tallest mountain in the solar system. It's one of the largest volcanoes ever formed anywhere we know of. The total volume of rock beneath your feet is almost impossible to imagine. If this volcano could somehow be transported to Earth, its enormous weight would begin crushing the planet's crust beneath it. Earth's stronger gravity and constantly moving tectonic plates simply couldn't support a structure this massive for very long. The mountain you're standing on wasn't built in thousands or even millions of years. It grew through countless eruptions spread across an incredible span of time, with each new lava flow slowly adding another layer to an already gigantic volcano. Every meter beneath your boots tells the story of another eruption that happened millions of years before the next one arrived. And perhaps the strangest part is that despite standing at the highest point on Mars, it doesn't feel like standing on top of a mountain at all. There's no sharp summit, no towering peak above you, and no dramatic cliffs falling away on every side. Instead, you're standing on a vast volcanic plateau so enormous that your brain struggles to recognize you're actually on the summit of the tallest mountain in the solar system. Only when you look back at the incredible journey you've completed do you realize what you've actually climbed. So why does a giant dead volcano on a cold, dry planet matter to us? Because Olympus Mons is a record, a roughly 3 billion year timeline of a planet's volcanic history, preserved almost perfectly because there's no wind erosion, no rain, and no shifting crust to erase it. Studying it teaches us not just about Mars, but about how planets form, evolve, and eventually go quiet. So why does a giant, dead volcano on a cold, dry planet matter to us? Because Olympus Mons is a record, a roughly 3 billion year timeline of a planet's volcanic history, preserved almost perfectly because there's no wind erosion, no rain, and no shifting crust to erase it. Studying it teaches us not just about Mars, but about how planets form, evolve, and eventually go quiet. It's also a reminder of how differently worlds can turn out. Change the gravity, change the tectonics, give a planet enough time and one fixed spot to keep building, and you get a mountain nearly 3 times the height of Everest, wide enough to cover an entire American state. If this video helped you picture just how extreme our solar system really is, that's exactly what this channel is about. Drop a comment telling me what planetary feature you want explored next. A moon, a crater, another volcano, anything. Hit subscribe if you're not already, tap the bell so you don't miss the next one, and I'll see you in the next video.